It's time for Dapper Dino!
Okay, so hello and welcome to my new channel on Unity game design. In this first video here, we're going to be going over the basics of coding that's necessary for making games in Unity before you dive into the deep end. Most of this video will be focusing on the console and rather than visual gameplay. And the first thing you're going to want to do, if you haven't done it already, is make a new project. I've just made one, call it anything you want. And we want to save scenes right away. We'll call it scene 101. And then we want to go up to the build settings at the top and make sure we add open scenes to the scenes in build. Because when you press play, it runs these scenes in order of how you've got them laid out here. And if you don't have your scene in here, you'll get an error. So make sure the scene you've got open is on the scenes in build order. Now we've got the scene here. That's where we are. We're going to be focusing on just coding rather than any visual things. So first of all, actually, you need to create an empty game object, and we need to click on inspector here first. So this is the object in the scene. It's nothing at the moment. Reset transform here, just to put it into the center of the screen, into the center of the game world at coordinate 0, 0, 0. And this object is going to act just to run our code. So if you click on here for add component, it has all the components in the game, all the pre-made components. But if you enter a name of a component that doesn't exist, you can make your own. So we'll call it coding basics. There we go. New script, and make sure it says C# because I don't know. Oh, there's only C# now. Anyway, create an add. And what it'll do is it'll add this code script to this object in our scene, and it'll put it down here, which is where it is in our assets menu. If you get more, you might want to make folders to sort everything out, but for this, it's simply going to be the scene, the code. So I'm going to leave it there. Now, if you double click on the code or click on it on the object twice, it opens it in Visual Studio, and there we go. So this is what every code script that you make will look like at the start. It has the usings, which are the libraries that it uses. So system, collections generic, and of course Unity engine, all the special things just for Unity. And you will have a public class by the name of what you named your script, and it uses mono behavior, which is the default, and most code you make will be using mono behavior, so don't worry about that just now. And then it already starts off with two methods, void start and void update. Now I'm going to assume that you don't know anything about coding. If you do, then feel free to skip ahead. But what a function is it's in between these two brackets, these curly brackets, this gets run. So any code you put in between here will get run. Void start, the keyword void, means that this function, when it's run, doesn't return any values. And since this code, wait, let's just get rid of these. I don't like these little comments. Okay, so void means it doesn't return any values. Start is a special Unity method, which you can't make another method called void start, it won't work. Void start means this code inside here gets run as soon as the object with the code it appears or is made in the object in the world. Sorry. So as soon as this code starts being alive in the world, this code gets run. And similarly, void update is another Unity specific method. Update means that the code in here gets run once every frame. Assuming that your game's going to be running in 60 FPS, this code will get run 60 times a frame. 60 times a second, once per frame. Anyway, so first of all, we're gonna leave out void update now. It's not necessary. We're simply going to start in the void start. So the first thing we're going to do is make it so that we can print text to the console. So there are multiple different ways of doing this. One most people are familiar with is print, because it's used in more coding languages than just C#. C# in Unity has other methods such as other code such as debug.log, which means it does the exact same thing, but you can have debug.log, is it error? log error. Yeah, that was right. You can have debug.log error, which when you put something in the console, it will have a different icon, which lets you know that it's meant to be an error message rather than notification. Anyway, we'll start off just using print. So print, and then assuming that you know a little tiny bit about coding, if you put a word in here, like say you wanted to say hello, this would not work because you want it to print the text hello, and as you might already know, a number like 4, or well, I put in 2. 2 is an integer, a whole number, and 2.5 or 2. Keep saying robot. 2.4 is a float, and in Unity, a float you have to put f. A float is a just a number that it can be decimal. It can also be like an integer number. You can have 2f. It doesn't have to be. And as well as numbers, there's also letters where you can have strings. And strings are always between speech marks or apostrophes, both work. And that just means it's plain text rather than anything else. So if I want to print hello, really I should do this. And now you want to save, and the shortcut for saving is Control S, as in anything else, or you can press save here. And when you go back to the game now, if I press play, assuming I've not done something wrong, if I click on the console here, it says hello. And we'll also go through these little buttons here. So clear, when you click on it, clears the log, so clear, it's gone. Collapse means that if the same message gets output more than once, rather than spamming it all the way down here, it just adds a little 1 to a counter on the side. So I'll show you that in a second. Clear on play just means it does the clear every time you stop and start the game. And error pause means the game will pause itself temporarily when there's an error, and then you can press unpause to carry on. Anyway, so let's stop and we'll go back to our code. So all this does at the moment is when the item is first started, when this object in the scene appears, this game object, it will print hello to the console. That's simple enough. And now what we can also do is we can go back and make void update. Now, if you just press enter to autofill, it'll make private void update, which technically will work, and there's no problem with that, but I just like leaving it as void update, simply because you don't want to start thinking about privates and publics yet when you're just starting out. That's not necessary to think about. It doesn't make a difference. You can do it if you want, but it's not a problem. Anyway, void update, as I said, runs every single frame. So if we put print and just put a different word like howdy, and we go back in here and press play after saving, remember, what it's doing is it's printing hello once at the start, and as you can see this number is going up, it's printing howdy every frame. If I get rid of collapse, you can see it's just spamming all the way down. That's why collapse is helpful when you're doing something like this. So that's showing this code is getting run every frame of the game. And one other thing to note is that if your game isn't running perfectly at 60 frames per second, you'll lose lines of code that you might expect. Like if you wanted to rely on something to happen 60 times a second, but your game was lagging a little bit, you would use void fixed update. This guarantees the frame rate as such. Doesn't make the game run faster, it's not that powerful. It just means the stuff you say, so like, what is it, howdy, we'll go for goodbye now. Goodbye. We'll save it and go back. And then now, when it restarts, you'll see. Now my computer is pretty good, so you won't notice much difference between these numbers. But on a slower machine, you'll definitely notice that. Well, wait a second. Ah, okay, yeah. So what this means is the fact that goodbye has less than howdy is meaning that the game is actually running at higher than 60 FPS now, which makes sense. On my laptop, this would not be it would be the other way around because it's laggy. But since the game's a 60 FPS game, this fixed update will do it 60 times regardless of anything, whereas this update will run at whatever the frame rate is. So because I'm just looking at an empty scene with nothing in it, it's not going to be laggy at all. Therefore, it has a higher than 60 frame rate, and the number's higher because that went up. There's an extra 400 of those, so that's quite interesting. Actually, I didn't think about that. Anyway, it makes sense. So next, I'm going to do variables. So, assuming you know what a variable is, well, assuming you don't actually, let's say we wanted to have a number in our thing. So what we'll do is we'll get rid of these updates right now, and we will print 1 plus 1. I like having the spacing. If you put a semicolon at the end of the line, which is necessary in C#, it will auto space everything to be nice and neat, which is always good. So if you print 1 plus 1, and I'm not being an idiot, yeah, it prints 2, because obviously 1 plus 1 is 2. And let's say you then wanted to print 2 plus 2, that would be, basically this is just multiplication, so let's just do, well yeah, times 2. And then you can put whatever number you want at the start. So 2 times 2, save, run, it'll give you 4. Makes sense? 4. But it's quite a lot of effort going in here and changing this number every time. So what we can do is we can put int, and then we could put number equals, and we'll start off with, well, we could put 2 here. And instead of having this 2 in the brackets, you can replace this word 2 with number. Whoops. But this word number doesn't have apostrophes or speech marks around it because it's not a string, it's a variable number, which we've already declared at the start. So now if you run, it should still say 4 because you're using number. And now, if you also say, for example, you wanted to print the number as well, you can do that. You don't have to re-enter the number every single time. And it also means, so we're going for 4 and 2 here. Now, if you change the number to like a big number that I can't be bothered reading, it'll say that number times by 2 and then that number. There you go. So changing a variable at the start, change it everywhere in the script, assuming you've declared it up here before everything else. Now, that's nice and all, going back into the code and changing the number and going in, but let's say you were making a game and you were testing what damage you want. Rather than coming in the code every time and blah blah blah, typing in the damage, you can do this. You can go public space int. There's a public integer number. Now, let's just not set it as a value, let's just leave it like that. So public int number and then semicolon to end the line. Now if we go back into here and we go into our game object, just the empty game object with the code on, and you go into the inspector, you'll see now there is a number here. It has that number in because I had it saved from earlier. But anyway, now if we change this number to 50 and we press play, we expect in the console for it to say 100 and then 50. There it is. And then let's say we then just change it to 100 and then we press play. We go back into the console. 100. There, it works. So using public integers or public anythings, you can change them in the thingy. I'll do one other example quickly. Let's just, oh, it's already stopped. So we can have public string name equals, and then you can put someone's name. So you could put I wonder whose name that is. Oh yeah. This would work, I think. Wait, no, it wouldn't, sorry. Okay, it would work, but it can cause problems at other points because name or .name is used in other scenarios that I'll go over in the future. So if you actually do want to use name, oops. Yeah, I'm being silly. It's new over here. Anyway, public new string name, Nathan. But I don't want to bother putting that in the code because I want to change it somewhere else. So instead of printing number, I'll just print name here. So what this is doing is it's printing the number variable times 2 and then it's printing the name. So if we go back in the code again to inspector, there's a new area here for name. And because I've said it's a string, it knows to give me a little text field like here. So I can put in, because if I put in letters here, well, I can't first of all actually. So that's one thing. Same with here. I think I can put numbers. Yeah, because numbers can be strings. But letters can't be numbers in this sense. It's not algebra, it doesn't work like that. So if I put my name, Nathan, and press play, 200, Nathan. And then one other little thing you could do, for example, is you could print in this bracket, you could print your name is. And the reason I'm leaving a space between is and the closing speech mark is that it prints that little space. Otherwise, it would just say your name is Nathan, where it would merge is and the name together. So obviously, if I press play now, I'll say 200 and your name is Nathan. And then I could quite simply just change this number to 200 and put this name as, I don't know, David or something. Ooh, that's not right. And press console. And there you go. So that all works very, very well. That's one good thing about Unity and Visual Studio, with the whole being able to use everything and change it all in the inspector if you ever need to. And then if you have settled on a value, you can always just go into the code and take away the public so you don't accidentally change it and leave it like that. But this works pretty well. And I want to go into something else quickly now. So we will move on to Booleans. So here we can have a private. Now, private is, as far as I know, the same as just not putting anything. So it's the same as just putting Boolean. But private makes sure that this Boolean or this variable can't be accessed anywhere else other than in this code. So it's very good if you don't want it to be changed anywhere else or, accidentally referred to. It's just safety, and it also helps in efficiency because if it's private, the code knows that it doesn't need to be used anywhere else. So private bool, and we'll call it is printing. The reason why I'm going to call it that is because I'm going to be, printing text. So private bool equals false. Yeah. So now we can go to the void update. And yeah, oops, sorry, I did it again. Alright. So now we can have it print something like, print. We'll go for name again. But maybe I only want it to print the name some of the time, not all the frames. So I could have if. Now a Boolean, if you didn't know, is a way of storing true or false data. So, if you want something to be on or off, true or false, however you want to phrase it, this is how you do it. So if is printing. Technically, the long way to do it is equals, which is comparing whether it equals this value, which is true. So if is printing equals true, but that, oops, I don't need a semicolon because this isn't if. I'll explain that in a second. If is printing equals true is the exact same as just writing if is printing. And when you write if is printing equals false to check that, it's the same as writing if exclamation mark is printing. It's just inverses it. Anyway, so I want to only print the name when, is printing equals true. So I'm going to take this and put it inside there. So it only prints this every time if that is true. Okay, so we'll go in here. And that means it shouldn't print because it starts off false and it never gets changed. So it never prints the name. I mean, I'm just going to actually print a string saying, printing. That's one way to do it. And then now, this is private bool. Let's change it to public. This is one way you can change a Boolean. And because it's true or false, the way Unity shows it in the inspector is as a little checkbox. So I can turn it on and check in the console. And as you can see, the printing is getting done every frame. This is on, it's been run every single frame. And we can turn it off. And it's stopped. And so on. So that's really helpful. And then you can have other ways of turning Booleans on and off. So let's say, put it back to private now that we've tested that. And we can have another thing in the void update before it. Now we're going to do checking for input. So we actually have something we can do. So we're going to have it check for input. Let's say we want it to be printing that text whilst we're holding down spacebar, for example. So if, so it's checking if, and then the code for checking input is starting off with input dot. So that's using the input method, and then get key. Now there's all these different ones you can use, and it depends on the situation. But for simply checking a button press, you want to do get key, and then there's get key down, get key up. And what it means is get key is checking, is the key pressed? Have you got the spacebar pushed down at that frame? If so, do the thing. If it's on get key down, it means did the spacebar get pushed down this frame, but only this frame, so it gets triggered once. So let's say you had a jump mechanic in a game. You wouldn't want it to be on get key because it would just constantly be jumping as you held your spacebar down. Whereas like in a flying game where you want to go up as you hold spacebar, you want get key. Get key down and get key up only happen on the frame when the key goes down or the key goes up. So we want it to be on get key. So every frame when spacebar's down, it prints. So input.getKey, and then you open the brackets. So this is what key it's getting. And here it gives you a little hint, kinda, of what it wants. It wants a keycode key. Now, keycode is what stores all the key codes in the game. So for example, if you start here, it's in alphabetical order. A being the character A, and these alpha whatevers being the numbers on your keyboard. So like 1, 2, 3, 0, 1, 2, 3, 4, all the alpha values are just the number keys. Alt, grammar, basically all of these are just things on your keyboard or joystick or yeah, whatever. Now we want to get the spacebar. So if you don't know exactly what key code is and you don't want to bother looking it up, you can just start typing in space, and you see it simply is space. So that's good. And then after the end, you want to put your curly brackets and open it. So this code is what gets run when you're holding down the key code. So when you're when you're holding down space. So when you're holding down space, you want is printing to be equal to true. The reason why you only use 1 equals here is because you're setting it. Whereas if you use 2, it's checking it. But you don't want to check it. You want to set it to true. So at the start of the thing, it checks, are you holding spacebar? If so, this is true. And then if this is true, it's printing. So I know there's a problem with this. I'm doing it on purpose for the learning experience. So you'll see it has that stuff, and I'm going to press spacebar. Make sure you've got the game scene selected because it's technically running the game scene. So I'm not holding down spacebar now. I've just tapped it, and you see it's still doing it every frame. And the reason for that being is because it checks whether the key's down, sets it to true, but it never sets it back to false. So if you want it to be only while you're holding down the spacebar, you want it to be, so if get key spacebar down, and then you want to use what's called an else or an else if, which means it does this check if the first one isn't true. Now because the key code get key down, get key can only be one or the other. It can be down or up. So if this isn't true, if your hand's off the keyboard, it will run whatever is in the else. So if this else this, so this is the code that gets run when you're not holding it, is printing equals false. Now there's technically a more efficient way of doing this where you could use the get key down and the get key up, because what this is doing is every single frame it's setting it to false, which isn't necessary because it's already false. So it works. It's not the most efficient way, but sometimes you don't start off by doing it the most efficient way. You then make it better after. So let's go spacebar and let go. And it stops. Spacebar and let go. So this is good for checking stuff that's happening only whilst you're holding the button down. As soon as you let go, it stops, which is really useful as well in games. There's a lot. All of this will come into games, even though it seems pretty pointless at the moment. Okay, now one other little thing I want to show you is, so here we have the void start method and the void update method. But what if you want to make your own methods? So let's say, for example, we make a void print name. And the reason you do these brackets is this is where parameters go if you ever need them, which we will in the future, and I'll explain that then. At the moment, you don't need any, but you still need to say that there's none, otherwise it won't read it right, the syntax problems. So, void print name, what do we want this to do? We'll just have it print, name. So what, print? Yeah, name, sorry. It's called name. I'll just put I'll put the thing here, your name is blah blah blah. Okay. Now up here where we've got print your name, you can simply just write print name, which is the method, and make sure you have the open and closed brackets for the no parameters there. And then that means now, rather than rewriting that code everywhere, we can just write this print name thing any way you want to run the method. So let's just say here, for example, you want it to print your name whenever. So when it gets to this print name thingy, it'll run this method down here. And then when it gets to here, it'll also run it. So now how the code should work is, when it starts, it should print it once, and then when you hold down spacebar, it should keep printing it. So it says your name is David 1, hold it down, your name is David, and it does it however many hundreds of times, and then I'll let go, and it stops. Start, stop. That all works pretty well. Is there anything else I need to cover this video, I wonder? I feel like I've done enough this video, but just to show right at the end, the keycode thing is really easy to change, because you could have, for example, get keycode up arrow, and you could have get key down. So this check, as soon as you tap the up arrow, it'll set it to true, and you can have else if. Keeping in mind, if you put an if, you have to then put what you want it to check. So if input dot get key down, keycode dot down arrow makes it false. So now how it would work is, it would start off false. If I tap the up key, it'll set it to true. Tap the down key, turns it to false. Up, down, you know, you see. It all makes sense. Anyway, I think that's been quite a lot actually for the first video, but I hope it gives you a good understanding of how to start coding in C# and Unity, and the other videos, tutorials, will teach you how to use this in practical ways in the actual making a game. But yep, I hope you've liked this first video. Please give a like and subscribe, and I will make sure to do more. Thank you.